Welcome everyone to the final presentation of the National Center for Supercomputing's Center for Artificial Intelligence Innovation Spring Seminar Series. My name is Melanie Moore and I'm one of the project managers here for the AI Center. I would like to introduce our speaker today is Sanjay Patel. Sanjay Patel is a professor of electrical and computer engineering here at the University of Illinois. He is the co-director of the IBM Illinois Center for Cognitive Computing Systems Research and technology advisor on the Rockwire Initiative. Sanjay's research has focused on computer architecture and massively parallel chip design with a focus on emerging use cases. For the past 15 years, he has been involved in numerous startup activities, including CTO of Agea Technologies, acquired by NVIDIA, and CEO of Personify, acquired by Foxconn, and more recently, under Rock Metro, Trovia AI, Digital Gemini, and EarthSense. Please join me in welcoming Sanjay.
Thank you, Melanie. Pleasure to be here today to talk about Alchemy, which is, sort of an outshoot of all the startup activities I've been doing for the past 15 years, some of which that you mentioned, Melanie. So Alchemy is a new program here that we're trying to install within the Granger College of Engineering. Let me share my screen and you can see the slides. So it's a new program we're trying to install here at the Granger College of Engineering. And the way I like to think about it, Alchemy is a prototyping lab where we, bring our best and brightest students to bear on the stuff that we are all working on in the lab in hopes that we can catalyze some real beneficial commercial activity with that. That's the overall idea with Alchemy. And let me spend a few minutes telling everybody some of the details. We'll go through some of the case studies. We've been running the program now for about 2 years and generate some discussion. I'd love to hear feedback from the people here, as well as questions. And by the way, feel free to interrupt at any point. I think that'll make the presentation a little more interesting if there's dialogue as we go through. Okay, so let me just get into it. About 2.5 years ago at this point, I was just at the point of having my latest company, Personify, that Melanie mentioned, handed off to Foxconn. And I was starting to re-engage with some of our faculty, Wenmei Hu, along with a few colleagues from IBM through the C3SR Center, thinking about what we could do to really catalyze this commercial activity, especially as it related to the research we were doing. And from that dialogue, Alchemy kind of came out of it. What we realized in that discussion, now 2.5 years ago, is there was something missing. We have students here, very bright students, that are doing things beyond what's required of them in the classroom, projects. Some of them are even trying to start companies. We've got the university, the faculty, the research expertise, the facilities. And what we're really missing here in central Illinois, despite having incredible facilities and incredible skill set and people here, is really a tighter connection to the commercial marketplace, where we can understand what are the problems that need to be solved and really understand the context in which startups are created. So the first idea with Alchemy was to really bring all three of these things together in a meaningful way, where we can bring students, ideas in our lab, together with partners like companies, investors, other entrepreneurs, and the three parties together identify problems that need to be solved to create sort of commercial potential. That was the idea. Okay, so these top students working with faculty members with problems identified by the commercial world work together over a long span of time, not one semester, but 3 semesters and a summer, 18 months, to really kind of put these prototypes into action. That's the fundamental idea with Alchemy. And let's kind of drill down into that. And I'll show you some very interesting case examples as we go through this. So kind of the nitty gritty here is we have this flow we've created. And ultimately, it's a curricular flow, meaning students kind of enter the program by applying late in their academic career. They could be juniors, undergraduates, juniors, seniors. They could be master's students. In some cases, they can be PhD students. But the idea here is they apply for Alchemy, not knowing what they might work on, and not knowing the other teammates they might be coupled with. So the students apply, and what we have is a framework in place to help them identify very interesting projects to work on. Again, projects that have this commercial potential. And we provide them an infrastructure to succeed on these projects, and also to meet other teammates that that can work on these things with them. So students come in as individuals. They quickly form teams in that first semester. And they identify projects to work on in that first semester. They could have a project in mind when they come in. They could have a team in mind, but that need not be the case. They kind of flow through the Alchemy framework for 3 semesters, plus a summer, with opportunities to interact with graduate students and faculty that are domain experts within the particular project that they've identified. They work with users and customers and potential investors along the way. And Alchemy provides project management and development experts. Things like AWS experts for cloud technologies, or software lifecycle experts, just so that the students get an idea of what it is to build real and commercial software. And then the output of all of this, after these 3 semesters plus a summer, is to see some real prototypes that are generated, potentially things that end up in the open source, and tools and demos, right? The idea here is we want to see something tangible come out of this at the end of the day. And with those tools and with the open source and those prototypes, the idea would be that we see a greater number of these teams go and seek funding and create real startups that are coming out of this program. Okay, so now what we have done is we've created the framework so that students actually get credit along the way. So there's each semester they're enrolled within Alchemy. There's 3 credits that they can get, technical elective credits potentially, in Granger for working on these Alchemy projects. Semester A, when they're early on, just let me flip back a slide. We call the first semester, semester A. The second semester, semester B. It could be intertwined with the summer. And then the final semester, semester C. And the idea here is that in semester A, they're really trying to identify projects that they want to work on and building some initial feasibility of those projects. And they're also trying to find teammates to work on. Semester B is really about prototyping, right? To build something that they can start to show the world. Semester C is really about taking what they've built and starting to take the next step from a commercialization standpoint. Maybe speak with investors or customers or users so that they're ready to launch out of Alchemy into a bona fide startup. Okay, so the program itself within Granger would involve things like the curricular management to make sure that the educational outcomes are being met for the students, as well as doing recruiting so that undergraduates and master students are made aware of this. Um, and the admissions process is working, connections to industry, entrepreneurship training, with the vision being that once we've managed it and scaled it, we have hundreds of students going through this process every semester and sticking with it for those 18 months. And along the way, people like people within NCSA, people within Granger, faculty, researchers can engage with these teams, potentially even make project pitches so that there could be something that a faculty member who's working on a technology within the lab can pitch to a team that's entering the Alchemy program and kind of walk with them through the process to build a kind of a bridge towards commercialization. And that again, coming back to my first point, was one of the things that we observed was missing within our ecosystem here at the University of Illinois. Kind of this prototyping process to go from the lab into the commercial world. And the way we think about it is the status quo here within most of our academic programs and most of our research programs is that faculty and students are typically driven by academic timelines and objectives, where we're very successful at getting out papers and occasionally getting out open source. But that's not enough. You know, the status quo helps us achieve great academic success, and we're quite good at that. And the idea here is by augmenting what we're already doing from an academic perspective with an Alchemy team, the idea here is to bridge into the commercial world with kind of a more acceleration, faster velocity. So these Alchemy teams kind of come in and then they can augment what's happening within our research programs to help through the journey into the commercial world. And that's the way I see it primarily. So, by the way, feel free to interrupt if you'd like me to clarify anything as we go through this. So now, what's at stake here? If we succeed with Alchemy, the idea here is we would have an increased amount of activity on the deep technology side within our campus. So more startups, but where the startups are engaged with kind of a deeper set of technology than, say, an app, for food delivery. Not to say that food delivery apps are easy, but they're not the kind of core technology that we, as a College of Engineering, a bigger research community, sort of are intrinsic to developing. So what's what we call deep technology. And then more of our research that we do here are translated into prototypes and open source. So it need not be the case that we create startups out of this, but that there's prototypes and open source that helps others, be it on a commercial basis or on a social basis, engage with the work we're doing within our enterprise here, our research enterprise. More engagement with industry, increased vitality of our undergraduate and graduate programs, more visibility of our research. And a really important one is more technology leaders. that come out of our programs here. So that's why the college leadership has really embraced this model as something that's going to be important and vital for us to move our engineering programs to the next level. Okay, so that's in concept what we are trying to do with Alchemy. Again, framework where juniors, seniors, graduate students at the master's level can get curricular credit for working on projects that are open-ended, but that leverage our research with the idea that we're trying to create more artifacts, be it open source, other types of engagement, prototypes, some of which we expect to lead into the commercial realm. So with that in mind, I'm going to get a little granular about some of what has happened with Alchemy over the last two odd years. We launched it in January 2019 as a pilot concept within the IBM Illinois Center for Cognitive Systems Research. And since then, we've had about 250 students apply. We've accepted about 40 of them. Again, we're looking for students that have the right propensity for open-ended projects, that are willing to commit the time across 3 semesters. So it's not for everyone, but those that have come in, I'll kind of paraphrase, have really found the experience incredibly meaningful. So we've had 40 students apply across 4 semesters. We've had multiple faculty that have provided subject matter expertise. So it's not the case that the faculty are proposing the projects. Sometimes the projects come from elsewhere. But then we find faculty expertise to supervise and advise, in some cases, these student teams along their journey. We've had an incredible amount of industry support from IBM, TI, Under, which is a unicorn startup in the radar space, Amazon, Twitch, Rock Metro, Magna, and a number of others that have provided financial support in some cases. They've provided access to expertise within their own domains, as well as a commercial viewpoint that has helped some of our teams now become bona fide startup companies. Total of 8 teams, and I'll go through them piece by piece. Okay, so what I'd like to impress upon you is that these teams are actually quite deep from a technology perspective. And in almost all cases, the students can, without really even a shallow understanding in the areas that they ultimately went into. Presense is a team that ultimately did some software, DSP, for imaging radar for the automotive sector. And that team, when they graduated, were given offers by a company working in that space because they wanted to ultimately get a team that was already conversant and knowledgeable about that space. And it was easy for them to hire in bulk. That was one of our very early successes. Converge, another team working on group decision making, that ultimately went and is now part of the Rock Metro team that I'll talk a little bit about in a moment. Some of these I'll do a deeper dive on. Digital Gemini, I'll do a deeper dive on, and it also involves radar and synthetic radar data. So I'll get into that in a moment. And as well, Vertex AI, which is now a company called Trova AI. We've had a team working on audio enhanced AI. or AI enhanced audio, I'm sorry, a team called Live Census, a team working on AI-driven podcaster tools, um, a team that has helped build some of the key technology that's in Safer Illinois. And I'll actually do a little bit of a deep dive on that team, CodeTracer. And then our newest team, Team Jalapeno. They haven't really picked a compelling name yet. It's kind of their code name. That's working on autonomy in the autonomy space on something involving teleoperations. So that essentially is like remote control driving of uh, autonomous vehicles that cannot operate in autonomous mode for whatever reason. So those are the 8 teams we've had go through the pipeline during this pilot phase. Okay, and what I'd like to do is kind of deep dive into 3 of them, just to give you a taste of the kind of work, the depth of the work that these teams have been able to do. And I'm going to start with Trova AI. Trova, when it was in the Alchemy program, was called Vertex. It was one of our, our 3rd or 4th team that we had entered the program. The team actually didn't know each other when they started the program. They came in as individuals, they met each other in fall 2019. We had some input from an investor, an outside investor, that said, NLP, natural language processing, is a very interesting technology from a commercial point of view. And wouldn't it be great if we could leverage NLP, which is, kind of a very hot area of AI right now, language AI. If we could leverage NLP to make better sense of all the stuff that's happening on chat and email. This is input coming in from an investor, a major VC in Silicon Valley. So we decided, okay, that's a pretty good signal. Let's see what we could do within Alchemy for that particular semester. So 4 master's students, 1 undergrad, started working on this. That's what they decided was their Alchemy project. They ended up partnering with one of the postdocs within C3SR, who had already started working on an NLP platform of his own. This is Omer Anjum. He started to advise them. And eventually, what they ended up building was a search platform, unified search platform that uses NLP to search across Slack, email, cloud documents, chat, and other platforms, what we call the personal web. There is the public web that Google searches, but then there's the personal web that right now there's no clear search for any of that really works. So based on a demo that they developed in fall 2020, so this was now about 7 or 8 months ago, they were able to secure about $300,000 in seed funding to create a bona fide company. So they ended up exiting the Alchemy program and creating a startup company. So the idea behind Trova is that, if you go to Google and you type something like you see here on the screen, find the white paper that Jim sent me last week, which seems like a reasonable query. Obviously, it's not going to work, right? But what you'd love to do is be able to type that and find that white paper, which Jim might have sent you through email or Slack or something else entirely. You're not quite sure, you might not remember, but you'd like to be able to find it quickly. And that is the whole premise behind Trova. So let's kind of take a deeper dive and understand kind of the technology that Trova developed, or this team developed, while they were working through the Alchemy program. Again, the undergrad, the master's students and the 1 undergrad didn't know each other and they only had a cursory understanding of the NLP space. But it was an intense period of time for them to really learn and work with experts in this domain. So one of the first key technologies they developed, very novel, they published a workshop paper on this, was the idea of taking these entangled conversations. Like if you look at your Slack, if anyone here, you uses Slack, you'll appreciate it, especially on channels where there's lots of people talking. Topics tend to get entangled with each other, where you have one person talking or writing a message about a topic A, that gets interleaved with topic B coming in from another person. It's common on channels that have multiple people that are participating. So if you look at the conversation history, these topics tend to get interleaved, which makes search really difficult. Search in general is difficult here because people aren't sharing very much, right? These turn by turn dialogues tend to be very terse, often with emojis and text speak, right? So they're hard to parse from a language perspective. So Trova created this disentanglement model that was based on an LSTM model to take these conversations and to really disentangle them based on topic. So once we have these disentangled conversations, we're able to do search much more effectively. That's a key piece that this team had developed. Now, this piece had to be embedded within a larger search engine that incorporated these language AI pieces all throughout. Not just disentanglement that you can see here in the green box, but things like being able to take an email message and embed the message, maybe phrase by phrase or paragraph by paragraph, using state-of-the-art transformers like BERT into a vector space. Okay, and to do a variety of other types of parsing and understanding of these email messages and chat messages and documents so that we're able to easily search through them. Okay, and this ultimately became the Trova search engine. So students identified the problem, they came in, they started taking pieces, they built a little bit of AI themselves, but they were able to leverage work like BERT and a few other word to vec and phrase to vec type of transformers to build a fuller system very, very quickly. And of course, to take all of this stuff and embed it into an AWS architecture where the search can essentially be done in real time. Okay, so that by and large is what took them, was their alchemy journey. A lot of their focus, a lot of their cues coming partially from some of the experts on campus and partially from lots and lots of dialogues with investors and customers and the outside world as to really what it is that they should build. Let me do a quick demo because at this point, Trova is on its way to get users ultimately. Their demo is not yet public, but let me show you what it is. This is the idea here. It's essentially a search bar, right? It's a search engine, and it's you can type in a query here, and it searches all of your personal stuff. So it's not necessarily, it's not searching the web, but rather what it's searching. And I've already created an account here, so I can show you that it's going to search any Gmail account that I connect up or any Slack workspace that I connect up, and I can connect Outlook or Dropbox or Google Drive, Jira, and you can see all the types of services. Much of, in fact, all of this is primarily text-based, natural language-based text, and I'm able to connect it all up here. Okay, so again, these are my accounts, and so I can come here and say, well, I'm looking for, say, a lease agreement that somebody sent me. I don't remember who sent it. I don't even remember where they sent it. But Trova, through the backend architecture using um, the things I had mentioned, lets me kind of get to a point where I can find that lease agreement. This is now on Gmail here. And then I've got a way to go and trace it down. Okay. So anyway, that is Trova. One of the companies, now at this point, a company that has spun out of Alchemy. So let me switch gears. By the way, if there's questions, now would be a great time to talk about Alchemy or Trova. I'm going to talk about another Alchemy team, but let me pause here, take questions if there are any. Be sure to unmute yourself. Okay, a question in the chat from Daniel. Does the university take percent of the company? This is something we are trying to work out right now with OTM. We've defined kind of an IP policy very carefully, working with OTM and working with the OVV, the vice chancellor for research and innovation around the Alchemy policy. But let me just say it's a work in progress right now. And the idea is that there would be some arrangement that an Alchemy team would have with the university around equity ownership as they enter into this. We're not quite there yet, but we're getting there. It's a good question. Any other question? Okay, cool. Let me switch gears and talk about another team. There's one more question here on the chat. What kind of role do you see PhD students taking in the future? Another good question from Daniel. We have to be a little careful with PhD students in the sense that PhD students, sort of, if they're sponsored, have an academic set of goals, kind of driven by their funding and by their advisor. So what we want to do is make sure this is not distracting to them, first of all, and that it's consistent with their academic objectives, with their thesis proposal, their qualifying exams, and the other things. So you have to make sure that's the case. And we also have to make sure that the funding agency doesn't encumber the IP that gets created in a way that's unfair for their teammates. That said, we see them being able to participate. Karen has a question. Can students flow into and out of the program, or do they need to commit to 18 months? Great question, Karen. And it's hard for anyone to commit to a long time frame like this, but we do ask that they commit because it's the fairest thing for their teammates who are potentially committing. But that said, life does get in the way. And sometimes you need to take a break or you need to leave. And we've had all of that happen. So we try to weave in some flexibility in the program so that, if there are circumstances where somebody does need to leave, that they can leave without it being an issue clearly, but that they can rejoin if that's the right thing for them and their team. Great. Okay, so let me now move to another one of our teams. And I'm going to use their presentation because I couldn't get the graphics to transfer cleanly into the other one. This is Digital Gemini. And Digital Gemini started actually the same time Vertex did. So this was January 2019. I'm sorry, September 2019. And Digital Gemini decided to go after a very different space. Again, with some input coming in from some of our contacts within the autonomous vehicle space. So in the AV space, autonomous vehicles space, machine learning solutions are very hungry for data. The way that some people like to put it is, just putting a car on the road is expensive. But now you've got to have that car drive around with lots of sensors, with a person behind the wheel for hours and hours to collect data that then can be used to train the data-driven algorithms that are going to reach, level 4 and level 5 autonomy. But the problem is, even if you put these fleet of cars on the road, again, expensive with all their sensors, to capture those scenarios that you really need to train the AI. For example, the grisly scenarios of, a motorcycle crashing into a highway embankment, right? Those are important, but they're rare enough that they're almost never going to get captured. So companies like Waymo, Waymo is leading the charge from an autonomy perspective, is that they're looking at complementing these millions of hours of real world driving data with simulation. In fact, it's almost 1,000 to 1 ratio in terms of simulation hours versus real driving hours. And it's probably going to grow beyond 1,000 because simulation is that powerful. And also because it's so expensive to collect that real driving data that matters. That's what we call the data bottleneck. Okay. Now, around that data bottleneck, the opportunity is really that simulation technology has gotten so good that we can generate these photorealistic environments that are, by and large, based on game technology. So it's cheap. You don't need a high-end system to do it. You can do it on commodity systems and real time. So fast simulation techniques, photorealism at a photonic level, things are great. But as you look beyond cameras, as you look at things like LiDAR, which are photonic, but they're different enough, and you look at radar, really, there's no high fidelity sensor models yet that are fast enough that we can use with these fast simulations to develop and generate this data in real time or faster than real time. And that is the Digital Gemini opportunity. That's what they went after. Let's putting a finer point on it. When we look at radar, right? Radar is this weird technology for most of us. You kind of imagine a spinning, transmitter disc at your airport, which is really kind of, where radar was born. In fact, the University of Illinois has such a strong legacy in that space, primarily born out of, wartime. Well, now similar types of technology are being put into cars, not even autonomous cars, but if you bought a car today with driver assistance like adaptive cruise control or collision avoidance, a lot of those things are built with these very cheap radars. So a car today might have 5 radar systems in it. So radars are going to be a key part of the autonomy solution. Why? Because we can build them rather cheaply. Uh, they're solid state. You know, unlike the radar that you see at the airport, where there's a spinning antenna, these antenna are fixed. They're solid state antenna, and they work through all weather, snow, fog. They work in the darkness. You know, things where cameras break down, situations where cameras break down. Um, Radars work extremely well. Problem is, um, now if we want to integrate these radar technologies into our simulation frameworks, a huge gap, because simulating radar is not a simple matter. You almost have to go back to Maxwell's equations and solve from first principle. At least that's, by and large where current uh, radar simulation technology is. So here we have Alchemy. The team identifies this as a problem they want to work on. They don't know a whole lot about radar or EM. They know a little bit about EM simulation, but they just kind of dive into it and build and build and build, and ultimately come up with a technology that's very new, but inspired by the way we simulate, um, the standard photorealism in these game engines, by building a texture map, except it's not a texture map. It's really a radio map. It's kind of the baking pipeline. So that's an offline pipeline where they essentially take something like a car, a 3D model of a car, and they build a radar map, radio map around that car, which then they leverage during their simulation pipeline, which is accelerated using ray tracing. Um, which, and now on a GPU today, an NVIDIA GPU, you've got hardware accelerated ray tracing. And they're leveraging that to really speed up the simulation pipeline to where today, effectively, they are doing high fidelity radar simulation in real time, which has been a breakthrough in itself. So we integrate all of this together, and they're able to generate radar maps in real time, things that look like these weird images here, that only a radar expert could really help you understand what's exactly going on, and I'm not going to bother today. So, and they've now taken this and they've integrated it into an ML flow where they're able to take these ML models and train them on this synthetic data that's generated from their simulator, and then show that these synthetically trained models actually work in real life. And it's pretty amazing. So this company, now out of Alchemy in the real world as a funded company, I think there's an incredible potential for them. But again, spun out of the Alchemy framework. Okay, so that's Digital Gemini. Now let me come back to my main presentation and just wrap things up here a bit. By the way, any questions about Digital Gemini? Good. My point is, again, student teams came in, didn't have a lot of domain expertise in these, very, I would say, specialized areas. But again, because of the resources here, the experts, the infrastructure, the content, they were able to get up to speed really quickly, and within a short 18 months, get to a point where there was something for them to continue on as a subsequent activity. Okay. Last thing I want to talk about is a mini team we put together, that some of you here, thanks to the Rockwire partnership with NCSA, some of you here know about. It was a team that right after the campus shut down in April 2020, that we decided, hey, why not put an Alchemy team together to help the campus fight the outbreak? So we got a number of people that applied. We picked 6 undergraduates who didn't know each other at the time. And we decided, hey, there's activity that's going on within Rockwire to build an app that the campus will use. What if we use the team or focus the team to build privacy preserving exposure notification within the app? And that's what we did. We spent the entire summer working with this team. It was very intense, almost 7 days a week through the summer of 2020, essentially building this extremely valuable technology within Safer, where we've got these 2 devices, device A and device B, and they're sharing these ephemeral IDs with each other through Bluetooth, where those IDs are effectively untrackable back to the originating device. So device B shares ephemeral ID B. Device A, who happens to be nearby device B, captures that ephemeral ID and now knows that device A was in contact with some other device that shared that ID. So with this protocol, which is, at this point about as privacy preserving as we can make it, what we can do is effectively create these databases where if device A turns out to test positive for COVID, that now device B, who recalls that they had seen a ephemeral ID A, can be notified that they're at risk of getting COVID. So this technology, we worked pretty intensively with the SHIELD team on campus, with Champaign-Urbana Public Health District, doing things that involved physical modeling to really understand, well, how long does device A and device B have to be with each other, near each other, in order for those IDs to be exchanged, ... And we integrated all of this within Safer to the point where the adoption rate of both Safer and exposure notification has exceeded our expectations. About 54% of people who use the app also enable exposure notification. And the incredible thing in my mind is the yield of exposure notification has been about 15%. Actually, I think it's trending higher. It's probably closer to 20%. So what that means is if you get one of those exposure notifications, and about 1,300 people on our campus have, there's a 15% chance that 15% likelihood that you're going to test positive at your very next test. So it's very effective at coming up with a meaningful signal to those that have been in contact with others. So Alchemy is not just about creating startups, it's about essentially doing good on campus and within communities. So final thoughts. Okay, these projects can achieve big things with the right structure and guidance. And through my experience, our top undergraduates, our MS and MN students are highly capable. They've got the background and they've got the horsepower, the intellectual horsepower to do big things. But the thing that I think I was most surprised by in doing this, that I didn't expect going into it, is they're extremely hungry for doing something beyond their coursework. Their coursework, it gives them some meaning, but they want bigger meaning. broader meaning beyond that, and they're hungry for it. So with that in mind, let me stop the presentation and would love to take a few questions.
Hi, Sanjay. This is Sandeep here. And nice to meet you.
Hi, Sandeep. Good to hear from you again.
Yeah, so I should also mention to the remaining of the team that we have collaborated on the Rockware project, as Sanjay mentioned, and I think I've been involved. I've worked with the two of the Alchemy teams, the Converge and the Code Tracer, for the Safer Illinois and Illinois app. So the question to you, Sanjay, is so it looks like there is like a very clear path for these commercial products or companies that can be, that can come out of Alchemy, right? So, but what about the non-profit, or like projects that most of us probably at NCSA work on, like where there is like a funding agency? Maybe you already touched upon when you talked about the PhD student question, but is there a vision for Alchemy in that space, or like a clear direction?
There is a vision. I think that we need not think about Alchemy as just a for-profit commercial activity. It's really about generating high-impact projects. Again, our involvement on Safer Illinois, I think the students really had a deep desire to do good on campus, right? That they saw the campus as something that was in need of a solution. And what fired them up and essentially drove them to work 7 days a week through the summer was this broader mission that, hey, if we succeed, we're going to help our campus community. So I really do believe that it's not just purely driven about, hey, I want to create a unicorn startup and make a lot of money. And that, drives some
Right.
students, but not everyone.
Thank you. Yeah, thanks.
Oh, hey, Jinjin, I just noticed your chat message here. I want to make sure that that I thank Jinjin. Jinjin is the co-director of the IBM Center, and I would say one of the founders of Alchemy. He was there in the early days when we were trying to figure out what Alchemy should be, and brought IBM much closer to Alchemy than would have happened naturally. So to that, I think I'm very, very grateful. And what I think that IBM has realized the value of Alchemy in the sense that, that gap between the academic world and the commercial world is a big gap. And programs like Alchemy can help bridge that. So in realization of that value, IBM has created a startup package for Alchemy teams, whereby these Alchemy teams get a variety of resources that are very meaningful, including cloud resources on the IBM cloud. And nearly every Alchemy team we've had has had cloud resources that they've needed along the way. So thank you, Jinjin.
Thank you, Sanjay. Yeah, just want to add, if it's the startup package thing, first case, of course, again, Sanjay, so to your credit and to bring these ideas up, and happy to be part of this journey and with you, right? And so we started this whole Alchemy, and just add to this IBM startup, right? It's not more than just only the cloud credit, right? It's also IBM. IBM had this venture kind of business, and this is really give students access, right, to broaden the network. And the reason before us being able to be qualified for this incubator, right, is because of the success, right? As Sanjay mentioned, out of these teams and how many things we can do. I mean, this is a success rate is way higher than the typical commercial incubator program. So that's why I'm, really a lot of credit to Sanjay for this for bringing this program to this level. Thank you.
Well, I would encourage anyone on the call on this webinar here to think about projects they'd like to propose, and certainly projects that they'd like to shepherd through the Alchemy process. I really think that's the true value of what we're creating here is a curricular means by which we're creating these prototypes. So if you have ideas, I would love to hear them. I'll help facilitate the connection to Alchemy teams.
Thank you, Sanjay, for joining us today, and we look forward to hopefully having you speak again.
Absolutely, Melanie. Thank you so much for the invitation. Bye-bye.
Thank you.